Hi, good morning, everyone. Today, we're going to talk about application-defined governance and what that means, how to enable that, and how open orchestration can help. I'm Sivan. I'm from the Cloudify team, and I'll share more about Cloudify throughout this session. So we've seen the cloud evolving, and if previously cloud was considered just a bunch of resources enabling compute, virtual machines, and really decoupling the software from hardware, this is no longer the cloud that we're experiencing today. We're at a reality of a service-oriented cloud where everything is available at a click of a button. We're not just talking about compute services anymore, not about network services or storage services. It's basically everything that we can imagine provided as a service. And we keep hearing our favorite buzzwords around DevOps, automation, enabling the self-service and consumption of everything the cloud can offer to anyone in the organization. And of course, this is incredible, right? We can provide services quickly. We can really see value from the cloud environment that we're running on. And organization can run with operational efficiency that have not been seen before. But there's also some challenge associated with this trend, because with great power comes great responsibility. And if we're looking at large organizations that operate in highly regulated industries, this automation and the ability to really consume anything on top of a cloud environment, which tends to be a multi-cloud environment with multiple locations, private and public, again, running everything that we can imagine, there's a lot of power when enabling users access to that environment. So imagine anything can be consumed with a click of a button, with just taking an API, enabling it, letting anyone in the organization run that, consume that. It means that as an organization, I have very little control over what gets done. And the more automation is enabled, the more we are targeting a DevOps approach, a self-service capability of the cloud, it means that resource provisioning is no longer something that the organization can necessarily control. The location of data, the cost, the resource consumption, security policies, and compliance with those. So this all becomes very hard to control and manage. And in highly regulated industries, this is a problem because there could be incidents, there could be breaches. We see all the time new regulations emerging and coming up. It's not just about GDPR. These are always around. And enterprises cannot afford an incident. So it's great to let everyone consume your cloud resources in the organization, but what if an incident were to occur? And we see many challenges for large organizations in these regulated industries with enabling full automation of resource consumption. This is a little problematic because we want to enjoy the power of the cloud. We want to enable that self-service methodology. We want to make sure that the DevOps and automation are not hindered by this need of control and governance. And the question is, how can we actually do that? So we see the solution as application-defined governance, and that's what I'll be talking about in the next 30 minutes. The idea is that an orchestrator, which is what enables us the consumption of all those services that we've seen before in an automated manner, an orchestrator actually fits between the application and generally any service that is provided on the cloud environment and the infrastructure itself. So with an orchestrator, assuming it was built with governance in mind, you can actually allow agility and automation alongside governance and control. So you can really define who can consume what, how, based on what regulations and what security rules and policies. And I'll be talking about some concepts that enable that, blueprints and tenants and role-based access control. So usually we hear a lot about multi-tenancy as a way to kind of isolate environments, and that's a great start. And we hear about role-based access control to some operations in the cloud so that only some users can do some things. But the way we at Cloudify see it, a missing piece that is very critical is what we consider a blueprint, which is a software-defined contract between the parties, between the operator who makes the cloud available and the consumer and users of that cloud. So I'll just give a short introduction to what Cloudify is, because I'll be using some terms and want to make sure that we're all on the same page. Cloudify was built as a multi-stack orchestrator. The idea was to decouple what needs to be done from how it needs to be done, so that orchestration can be done on any environment, on a hybrid environment, a multi-cloud environment, multi-stack, meaning virtual machines, containers, serverless eventually. And the way we enable that is through what we refer to as a blueprint, which is kind of what you see on the left side here. The idea is to model a topology of an application or a service and define what are the resources that are required, what are the dependencies between those resources, and what are some workflows, which are automated flows that need to happen to make this topology come alive. And then that same model can actually work on different environments. So the model is not tightly coupled with any cloud provider. It's not necessarily built for OpenStack or AWS or any specific provider. The idea is to kind of make that connection and association in runtime based on the environment that's at play. So when we started out building Cloudify, we really looked at the model-driven orchestration that I was just talking about. But we then realized that we want to make sure this automation and great power that comes with it is not something that hinders governance and control, and that organizations can actually leverage this platform as needed. And then we looked at those aspects and decided that the same framework has to work for the developers and for ops. So if you build an automation tool that's really targeting DevOps and the application users, I'm going to call it, then usually central IT and ops within an organization are going to find themselves with a problem. Again, that control aspect, the ability to really ensure that they know what's going on, but not just in hindsight, that they're able to control and define the usage of that cloud in an automated manner. And so it was important for us to build a common framework, but obviously that's not enough yet. Diving a little deeper into the model, and for us to understand why I was referring earlier to a blueprint as a software-defined contract, when I'm saying model-driven orchestration, automation, the idea is, again, as I mentioned before, to decouple the what from the how, and really create a flexible model of the application, which can then be translated to any environment that we're working on. But this happens with some interesting elements, which then enable the governance and control aspects that I was talking about. So it starts with a blueprint, which again describes the model of the application. And that blueprint is then understood and becomes somewhat of a topology graph, which can be traversed by something we call workflows, automated flows for provisioning, configuration, monitoring, scaling resources, any operation that needs to take place on the application itself. And I mentioned that we decouple what needs to be done from how to do it. The idea is that the how is determined by plugins, so what you see on the right side there. And this is a very important element in enabling this type of control that we were talking about. Plugin is basically what enables Cloudify to interact with any environment and any technology. So anything that's API-driven can be described, the integration with it can be described in a plugin, just a basic Python code. But allowing this as an element of the system, so it means that the environment integration is something that's decoupled from the application model, in a way. And when I'll talk about the governance aspects, then this will become quite handy. And then how does it all come together to provide model-driven governance, as we call it? So the blueprint really is a software-defined contract between the application developer, between whoever really decided to capture his model in a way that can be automated, and the IT operations, because this blueprint really determines and defines the level of automation that's going to take place. These are the resources that are going to be provisioned. These are the flows that are going to take place. And these are the entire operational life cycles that really can happen. As long as we use a blueprint as a contract, it means that ops know exactly what's going to happen when such a blueprint is going to be deployed. So there are boundaries to the application. And now let's say data services should not and cannot run in a specific industry in public clouds or in specific domains or locations. That contract, that blueprint, enables exactly that limitation or definition of boundaries, because the ops can really look at the blueprint, say this contract is okay, right? It complies with the regulations that that we're bound to, or no, this blueprint looks at a data service and provisions it anywhere. So this type of regulation is something that that can happen through this blueprint, that contract. But then there's another aspect. I mentioned before plugins, and that as a piece that integrates with different environments. So if we said that the blueprint defines the application boundaries, the plugins define the environment boundaries. And so if we need a way to ensure that only some teams in the organization can work on top of some environments, or only some blueprints and some services can run on, again, on public clouds. This is exactly something that the plugins and the ability to isolate those and permit plugin usage only to some teams in the organization, this is exactly what's enabled here. So basically, we enable an interaction on the same system to all those different users, the application consumer, the application developer, power user, and the IT operations. And through those tools and contracts that we allow them to use, the blueprints, the plugins, and so on, this type of interaction is made possible and is governed. And the idea is that anyone can then use an automation platform, an orchestrator, such as Cloudify, and we don't have to actually take back that power of that cloud. So DevOps is made possible, automation is made possible, self-service is made possible with some rules and some restrictions, which can be defined before an incident or a breach actually takes place. And so this is what we refer to when we define the application-driven governance. Another aspect is around networking. So we know that network is a big area that needs to be secured as well, looking at access to services and the way that even those automatically provisioned services access one another. And with Cloudify, we therefore are modeling networks as part of the application. And the idea is that we can automate the setup of any network service and automate the restrictions of network access to to the services that were provisioned and to different parts of the cloud environment. And so network security is enabled with either parts of the applications that allow for those to take place, like micro firewalls and such, as well as the ability to really define what are the links that need to be created and what are those that are permitted between the different parts of the cloud, between the different services that are provisioned on that cloud, and so on and so forth. I mentioned multi-tenancy before. Looking at environment isolation is always critical, of course. But an interesting way to do that with application-defined governance is, again, that blueprint, that contract, defines what are the applications that are that could be automated, what are the services that could be created on the cloud environment. And now we can actually define the organizational groups who can access those applications, either from an automation perspective, so who can actually provision those, or from a consumption perspective, so who can actually access the deployed resources. In Cloudify, the idea is the administrator can define also the environment consumption per tenant. So I mentioned before the notion of plugins. And again, plugins are really what can integrate with any system, any provider, anything really. So imagine a situation where Kubernetes is something that your organization starts working with, and you'd like to make sure that obviously, automation is very critical when looking at Kubernetes, but not everyone in the organization should use that tool. It's not yet understood what are the implications of running containers and so on and so forth. In this case, an organization can still bring up Kubernetes, integrate with it, create a plugin to do so, and actually, plugin exists to do so, but still only allow some users within the organization and some groups within it to use that new environment and the new tool. So again, the same framework and the same platform can be used by everyone in the organization, but used differently. Not just from the perspective of the operations that can take place and be triggered, not just from the perspective of what can be provisioned, but also what environments and what technologies are available for those different groups in the organization. So to summarize those different governance pillars that are made possible with an orchestrator and with application-defined governance. I started out talking about the blueprint, which controls how resources are used. And the idea, as said, is that we have an application, we model it, we define that contract, those boundaries of automation. And those boundaries are ones that cannot be crossed because this is exactly the model that is going to be enabled. I mentioned role-based access control before and kind of skipped through it. But with Cloudify, you can actually define who can upload blueprints to the system. So as long as that definition of who are the modelers of applications and blueprints, as opposed to who are the folks that are approving this type of automation and the boundaries that are associated with it. As long as these are kept, then we can really use that contract of a blueprint to ensure that we know what is provisioned and how it's provisioned. Workflows control how the application behaves in different operational lifecycle events. And again, this enables the IT and ops to really understand what's going to take place at each and every step of the way. and not fear the fact that they can't control it. So we see many organizations where manual approvals are needed in some steps of the application lifecycle. It sounds a little crazy, right? It's not automated. It's very much hindering the efficiency of the operational process, but it exists. And sometimes you would need that type of manual operation within a workflow. So mandating just not using any automation at all would mean, again, taking a huge step back. Enabling this type of automation, which is well-defined, creates the relevant boundaries, and still enables manual operations as needed, is a huge step forward for such organizations with such mindset. Multi-tenancy, I mentioned before, regarding the environment isolation, and role-based access control, which, again, controls who gets access to those different blueprints, to those different plugins for integrations with the environments at play. And network, again, a very interesting aspect of governance and control. And we see a lot of debate around who can actually provision networks, which really do allow connecting things that maybe shouldn't be connected. So enabling the same automation framework to work both on the application side and the network side, determining what is the degree of network isolation and separation that the application should have, that the different environments should have. Should it really be possible to connect the private and public clouds to an extent of, again, a potential breach? All of these can be controlled and should be controlled with network automation. And then last but not least, obviously, all of this should somehow be made visible to anyone in the organization at a different degree of visibility. So something that's enabled with the same framework working for both ops and devs is that different people see different things, obviously, and get their automation experience that's tailored to the role that they have in the organization, to what it is that they are permitted to do. And again, within those boundaries of the blueprints and plugins. And that's pretty much it. So to summarize, orchestration is what can provide central control over automation and application management, service management. And so even in highly regulated industries, even in large organizations which have to comply with many different boundaries and security policies, there doesn't need to be concern or fear of automation. And with application-defined governance, there can actually be organizations that embrace this type of automations and complete orchestration of the DevOps processes without being concerned about breaches, about isolation, about breaches and compliancy with regulations, and using those different pillars of blueprints and plugin and network isolation, we can really take everything that the organization provides, everything that the cloud enables, and make that automated without those concerns. So we have a bit of time left. Any questions? Yes, if you could step up to the mic, please. Oh, sorry, didn't see you there.
Yeah, I was going to ask if you could just go back to talk a little bit more about automation of your micro firewalls and describe that and the kind of applications that you're putting those against.
Sure. So let me go back a bit. I mentioned model-driven orchestration and the blueprints as a contract. So when we dive a little deeper into this notion of what a blueprint is, and maybe I'll actually go back here, the idea is to just model the topology of a service that needs to be brought up. Now, that service is not just limited and restricted to a compute service or a data service. We can actually automate anything in the same manner. And so as long as we define what are the requirements of a firewall, for example, or a micro firewall, we can define it as part of an application, either as a tier that has to be brought up with the application itself, or as a service that potentially already exists in the environment, but can be leveraged, so that one of the automated flows that I mentioned before of provisioning a new application can be to register and configure, create rules in an existing firewall, or potentially to bring up such a firewall with the application itself. The idea is that we can also ensure that those resources are tied together, so that there's not even a single moment where the application exists and the firewall doesn't. And vice versa. There doesn't need to be a time where the application was already deleted and the firewall still exists, taking up expensive resources. So that ability to couple all those resources together, creating dependencies between them, modeling them in a uniform manner, and then automating the creation, configuration, and additional lifecycle stages of those resources together is what enables exactly this. So defining the way that this application is consumed and defining the network security that is associated with it and enabling an automation of that network security.
So my question is it true that in this scenario nobody would interact with the clouds directly, but rather ship the applications to Cloudify, and then Cloudify would later deliver them to the cloud?
In a way, the idea is that anyone who interacts with the cloud doesn't, as you said, there doesn't need to be direct knowledge and expertise in a specific cloud environment. So if you think about it, in most organizations, there's a large cloud environment that doesn't comprise of just a single technology. And in addition, the technologies keep changing. We see OpenStack APIs evolving. We see AWS services emerging all the time. There were cute logos here before of all the new services and projects that are available with OpenStack in the latest releases. And so what Cloudify enables is just modeling the application. I mean, if I'm an application developer, I'm not necessarily an expert in those cloud technologies. So I can just model the application, what I'm an expert at, what I know best, and let those who are in charge of plugins to create that interaction with the underlying cloud environment. And then Cloudify really does leverage those APIs through plugins to interact with a cloud environment.
So let's say one developer wants to package their application for Kubernetes. Another developer wants to package just for a virtual machine in OpenStack. Mm-hmm. Today, they would just push it to their appropriate Kubernetes interface or OpenStack API. With Cloudify, is there going to be another person doing the plugging, or are they going to be pushing those applications to Cloudify API? How is that going to happen?
They're going to be pushing the applications to Cloudify API or through a user interface, the GUI. And Cloudify comes out of the box with plugins to all leading technologies, you can say. So, for example, there's an out-of-the-box plugin for Kubernetes and for OpenStack and all major clouds. But if they wanted to extend and enhance the way that this plugin works, and let's say a new experimental service is made available with Kubernetes and this application developer wants to use that, they can actually enhance the plugin and use that service. I haven't mentioned, but Cloudify is an open source product, so the code can be modified, and plugins are actually somewhat external to the architecture, so they can always be written and enhanced, and new ones can be created.
Thank you.
Thank you.
What's the intended separation of responsibilities for creating blueprints between the application developers and a separate security or compliance organization inside the enterprise?
Well, the idea is that these are those different personas in the organization have, first of all, a different mindset, second of all, different expertise, and then as long as we decouple and enable an application developer to focus on what he knows, which is the application itself, and then letting someone else enhance that model, potentially, with a security policy, with ensuring that compliancy is met, and so on, then the automation is made possible. Otherwise, there's a bit of a challenge because either we would try and make the application developer aware of all the security restrictions and everything they have to comply with, or we'd have to make security experts aware of those different applications and realize the services that have to be provisioned. And we usually find that this separation of concerns is actually what makes the onboarding of new services into a cloud environment much quicker, because we let each person focus on their domain and enable kind of a flow of developing that blueprint further. So you can start with a topology, continue with the operational automation, continue with security policies, environment isolation as needed, and so on.
So you're saying that the blueprint goes through many hands to be created?
If it needs to, but all those different steps that I mentioned can actually be external to the blueprint. So other than the topology and the initial automation, those plugins are what represents the environment, and they're separate to the blueprint. The security policies are also separate and can be defined later on. So it's not exactly the blueprint that changes hands. It's more the flow of onboarding it and including security policies associated with that specific type of service.
Thank you.
Thank you.
Hi, Sam Buari, Verizon. In the context of compliance, does Cloudify get into the specific compliance requirements such as PCI DSS? Is that something that can be used to meet those requirements, or can you elaborate a little bit on that?
It's a good question and a very broad topic. Cloudify can be customized and configured to work in such environments. In a sense, you can define the rules, define the regulation, compliancy that you'd like to have, but these are more of customizations that would take place afterwards. Cloudify is referred to as an open orchestrator. So the idea is that you can run it in many different ways, and you can configure the services and their automation in different ways. As long as if regulation compliancy is something that the organization needs, they would usually restrict all those different components that I mentioned throughout the session, and then add some rules to how things can be used, and so on. But if you think about it, an orchestrator is more of an enabler or restrictor of flows, more so than an actual system that handles compliance out of the box. Thank you. All right, great, thank you.